calculus video on 3.5 derivatives of trig functions. So first thing is you're going to have things like sine, cosine, tangent, and you're going to have to take the derivative of them. So it says the objective is to be able to solve problems involving derivatives, tangent lines, and trig limits. So why we're studying this is many phenomena of nature are approximately periodic, like electromagnetic fields, heart rhythms, tides, and weather. The derivatives of sines and cosines play a key role in describing periodic changes, and this section shows how to differentiate, which means take the derivative of the 6 basic trig functions. So first off, besides sine, cosine, and tan, you know there is cosecant, which is 1 over sine. You have secant, which is 1 over cosine, and you have cotangent, which is 1 over tan. The other thing that you may need to know, or you may remember, is SOHCAHTOA. Sine is opposite hypotenuse. Cosine is adjacent hypotenuse. And tangent is opposite and adjacent. So that's your SOHCAHTOA. Now what we're doing is not having to do with triangles, it's doing derivatives. But that's a refresher. Now, may seem really easy and everything, but the derivative of sine is cosine. It's a definition. So there you go. Derivative of sine is positive cosine. Okay, you might want to star it. Now, if all you're doing is taking the derivative of sine, it's easy, but maybe you're multiplying sine times anything, or you're adding sine times anything, etc. You also may have to use the product rule because of products, and the quotient rule, again because of quotients, like division. So you are going to use some of the rules in previous sections. So remember things like, for the product rule, I'm going to say u times v is u prime v plus v u prime. Or you could do it in the different order. That doesn't matter because it's plus. But for quotients, if you think of u over v, the derivative would be v times u prime minus u times v prime over v squared. So those are ones we're going to use. Now, the derivative of cosine would be negative sine. Again, that's just a definition. And we find the derivative of cosine in combinations of other functions. So that's the first part. So when I say see page 134 and 135, that's for your online textbook. Basically, here's a long explanation of why the derivative of sine is cosine. I don't feel like doing that proof. I just want to use it. Okay, so there's your proof right there. And then the derivative of cosine proof is right there, that it becomes negative sine. Again, I don't want to do proofs. This isn't geometry. And for high school calculus, we're not doing proofs on these functions. Now, what you are going to have to do are like the examples. And we'll show you our own examples like we normally do. Let me just adjust the angle of this thing. So you are going to have to do things like the derivative of x squared is 2x, because you take your power down and you have your minus, and then the derivative of sine is positive cosine, and that's your answer. So in general, they're going to be quick, but you do need to know your correct derivative. And even though the derivative of sine was positive cosine, you had to still keep your minus sign. Okay, so you are going to see things like that. You're also going to see it with the product rule. Let me get this angled right. Okay, so if you have x squared sine x, then you're using the product rule. So you could say the first times the derivative of the second, so derivative of sine is cosine, plus the derivative of the first, which is 2x times sine x. And there you have it. So that's another short problem. Now on this one, you have sine x over x. So this is a quotient rule. So you do your denominator times the numerator derivative, basically, and then minus the numerator times the derivative of the denominator over the denominator squared. So then bring down the x, the derivative of sine is cosine, and negative sine times 1 is negative sine, and bring down your x squared. So those are type things you're going to be doing, and you're going to do that with cosine also. But that's just a quick overview. Get this reset. Okay. So then there's also going to be some things with simple harmonic motion. Maybe it's just a definition. So what simple harmonic motion means is it models the motion of an object or weight bobbing freely up and down on the end of a spring with no resistance. So we talked about something kind of like this, or maybe you did during physics. The motion is periodic and repeats indefinitely, so we use trig. And on page 136, there's a picture. And you're not having friction because it's air. And we're not like in a wind tunnel where it would do air resistance or anything. Like, we're not going to do something like that. So here they're just showing you it hanging down, different lengths, and they model it with the trig functions. So this one went to -5, and they modeled it with these. This one went to 0. This one went to 5. 0 is the rest position. So this is compressed, and this is stretched out. Okay. Moving on. Derivatives of other trig functions. Like we said, cosecant relates to 1 over sine. I guess I list those here also, but so those are just basic. But then the derivative of tangent is secant squared, and the derivative of secant is secant tangent, and the derivative of cotangent is negative cosecant squared, and the derivative of cosecant is negative cosecant cotangent. These are definitions you're going to need to remember or just use your notes. Those are your formulas. The more familiar you get with these, the better and the quicker you're going to be. The way I kind of break it down is the derivative of the C ones are negative. I guess that's even true for cosine, because the derivative of cosine is negative sine. Okay, so that's just a little hint. Again, you are going to have to use product rules, quotient rules, and combination. You even have to get a second derivative, which is a little bit more complicated. But we'll just get to it in our own examples. Okay, so let's move on. So some of these are going to just seem very quick and easy to get, but don't take it for granted. You have to earn it and do it. So the first thing is you have a plus sign and you have 17x, and so when you take the derivative of 17x, it's just 17. And then the derivative of cosine is negative sine. So that means the 7 comes down and then it changes to negative sine. I mean, that's basically it. So if f equals 7 cosine x, you're not using the a product rule or anything. You're just bringing down the 7. The derivative of cosine is negative sine, and you just bring your negative in front. And we had already done the 17, so that's all that is. Now, for this one, you have 2 over x, and it's a plus, so let's do that first. The first thing we think is 2 over x is the same thing as 2x to the negative 1. This is your function, or part of the function. That's what I'm doing right now. So then the f prime would be 2 times negative 1 is negative 2, x to the negative 2. Now we write that as negative 2 over x squared, and that's what you can see for the front. Now for the back, I'm going to call it g. G equal 5 sine x. And so the derivative of g would be 5 times the derivative of sine, which is positive cosine. And then just combine it. This part was the f prime, and this part was the g prime. You don't really have to use f and g if you don't want to. I was just trying to make it easier to understand. Okay, now on this one, you're multiplying, and so you're going to use the product rule. So the first thing is this is going to be u and this is going to be v. So the product rule means uv. That derivative would be u times v prime plus v times u prime. That's my first step. So, or you can have it as v times u prime plus u times v prime. It looks like in theirs, that's the formula, or that's the order they want. This is the order. Now, it doesn't really matter because it's plus. So they're doing v first, which is sine x. And then you're taking the derivative of u. Well, if u is x to the 4th, then u prime would be 4x cubed. So it's sine x times 4x cubed. Now, what we do is we put this part in front so we don't think our angle becomes 4x to the 4th. That'd be a mistake. So that'd be 4x cubed sine x. In fact, if you really wanted to, I'm going to get a different color pen. If you really wanted to, you could have said sine x in parentheses, just so you don't confuse yourself. But that's completely up to you. Okay, so now we've done the front. So this part matches this part. And then we have our plus sign. Now u is x to the fourth. So we have x to the fourth. And then the derivative of v. So the derivative, if v is sine x, v prime or dx dv would be negative cosine x. Wait, derivative of sine is positive cosine x. And so that's cosine x. And so that's already in the proper order. So we have 4x cubed sine x for the front, and then plus x to the fourth cosine x. So this is your back. That's how it works. Now in this one, you're doing the derivative of secant. So if f is secant, then the derivative, you can flip your paper if you need to, derivative of secant is secant tangent. So we put secant x, tan x. And so that's all you do for the front. Now, skip the middle for a minute. The derivative of 4 is 0, because the derivative of any number is 0. So that's why there's not 3 parts. Now, the other part, I'm just going to call g, would be negative 7 square root of x. So we could rewrite that as negative 7x to the 1/2. Now for g prime, that'd be negative 7 times a half, which is negative 7/2 x, and lower by a whole number. So that would be like negative 7, put the 2 in the bottom, and put the x to the half in the bottom, but we just put it as square root of x, and that's what they have. So these two parts combined, right there, these two parts combined make that one. Okay, now on this one, we've got another one with the product rule, and then this one separate. I'm just going to call it separate. So let's say x to the 6th times the derivative of cotangent is negative what? Derivative of cotangent is negative cosecant squared. And then it's the product rule, so we have to have plus. And then keep your cotangent the way it is. And the derivative of x to the 6th is 6x to the 5th. Now for the last part, which I say separate, we'll put that as negative 1 over x squared, which is the same as negative x to the negative 2. So I'm going to call that f. So f prime would be negative times negative 2 is 2, x to the negative 3. And so we write that as 2 over x cubed. Okay, so that part just goes right there. Now, when we're doing these, we have to put the negative signs in front. So this is negative x to the 6th, and then you put your cosecant squared, and then we have our 6x to the 5th goes in front of cotangent x, and then we have our 2 over x cubed. Okay, well that's a good starting point for the first 5, so I'm going to stop the video there. Hope that helps.